Hi guys, okay, so we're going to go over the homework, the test review, part one. The first one says graph and determine the solution for the system y equals 3/4 x plus 2 and 2x minus y equals 3. Then check your solution in each equation, show your work. So we have our slope-intercept form here, and that shows us that our slope is 3/4 and our y-intercept is 2. So our y-intercept is at point 2. And the slope tells us to go 1, 2, 3 up, 1, 2, 3, 4 over, 1, 2, 3 up, 1, 2, 3, 4 over. All right, so we've got enough points that we can actually graph this now. So let's do our graph for the first line. And then, of course, we want to label that line. And we want to do it right away so we don't forget it. So y equals 3/4 x plus 2. And that's the first line. Okay, now we got that line down. Now let's do the second one. Then the second one we can see is in standard form, so we have to get some information here. Well, we know that the slope of this line in standard form is always negative a over b. Our a here is 2. Our b, well, we don't actually see b. It's hard to see because there doesn't seem to be a number in front of y, but remember the coefficient when you don't see one is always 1. Okay, so there is a 1 there even though we don't see it, and preceding the 1 to the left of it is a minus, so we're going to make that negative 1. And we also need that other negative in front because remember it's negative a over b. So two negatives gives us a positive and our slope is 2. Now our y-intercept, well, the y-intercept we know that x is 0, so the x disappears, and we're left with negative y equals 3. We don't want negative y, we want positive y. So our y-intercept would be at 0. Well, if this is turning positive, this has to turn what? Negative, of course. So we get our y-intercept at 0, negative 3. So 0, negative 3, there's our y-intercept, and our slope is telling us to go up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. Hey, look at that. We've got our point of intersection right there. So we can graph. We've got plenty of points to really make this a nice, easy graph to work with, right? And then, of course, we want to write down our equation. So our equation was 2x minus y equals 3. And now we've got our two equations down. And we have our point of intersection. That point is at 4, 5. Remember, x comes first, so it's 0.4, 5. And that's our common solution. That's the solution to this system of equations. So our answer for the system is at 4, 5. Now let's check it. So in our first equation was y equals 3/4 x plus 2, and our y is 5. Our x is 4, so we're going to put it right in there, and plus 2. Well, let's see, 4 divided by 4 is 1, so we're left with 5 equals 3 plus 2. And 5 does equal 3 plus 2, so it checks for that. Let's check on the second equation. The second equation is 2x minus y equals 3, and 2 times our x is 4, minus our y is 5, and that's supposed to equal 3. 2 times 4 is 8, minus 5 equals 3. 8 minus 5 does equal 3. So we're all checked, we're all good. We showed our check, we graphed it, we found our point of intersection, which we know is the solution to this system of equations. So we are done with question number 1. All right, so let's get to question number 2. Graph and determine the solution for the system 5x plus 2y equals 10 and 3x minus 2y equals 6. Then check your solution in each equation and show your work. So we know both of these equations are in standard form. In standard form, to find our slope is always a over b with a negative in front of it. Our a in this case is 5. Our b is 2, and we put a negative in front of it, so our slope is negative 5 over 2. Our y-intercept, we're looking for y, so we know x is 0. And if we look in there, 2 times what equals 10? 2 times 5 equals 10. And remember what we're really doing? We're dividing both sides by 2. So we get 0, 5. Our second equation, our slope, once again, is a over b, because this is in standard form. So we have 3, and there's a 2. The coefficient of y is 2, but there's a minus in front, so we're going to make that a negative 2, and we can't forget that other negative, negative a over b, so we end up getting a slope of 3 halves. Our y-intercept here, we know x is 0. Let's see what happens. Negative 2 times what is 6? Negative 2 times negative 3 is 6. So we have our 2 slopes. We have our 2 y-intercepts we can graph. So we'll graph the first equation first. That makes sense. We'll start at 0, 5. And the slope tells us to go down 5 over 2. Down 5 over 2. So our first equation, we can graph it now. We've got enough points. Graph it right there. And we want to give it a name right away so we don't forget it. The name of this graph is 5x plus 2y equals 10. So you name your graph by your equation. All right. Let's get to our second graph. Our second graph, we know our y-intercept is at negative 3. And the slope is telling us to go up 3 over 2. Look at that. We got our point of intersection already, so we can graph that. So there's our second graph. And the equation of that graph we know is 3x minus 2y equals 6. So we have both our equations. We have our point of intersection. There it is. Our point of intersection is right there. So what is that point of intersection? That point of intersection is at, remember it's a point, 2, 0. 2, and it's not going up and down, so it's 0. Remember, x, back and forth, y, up and down. So there's our common point, and that is also the solution of our system. Let's check it like we were supposed to do. So if we put it into the first equation, we get 5 times our x is 2, plus 2 times our y is 0, and that's supposed to equal 10. 5 times 2 is 10. 2 times 0 is 0. So 10 plus 0 does equal 10. It works on our first equation. Let's check our second equation now. 3 times 2 plus, sorry, not plus, minus, right? So we'll change that to minus 2 times 0, and that equals 6. 3 times 2 is 6, minus 2 times 0 is 0, equals 6. 6 minus 0 does equal 6. So we checked it in both equations. Our solution works in both equations, so we know we're right. We graphed it like we were supposed to do. We labeled both graphs like we were supposed to do. We found our point of intersection, and we did our check. We are done with question number 2. Question number 3, we're told to answer each of the following based upon the graph and information provided by the equation 8 plus 4y equals 24. So what is the y-intercept of this line? Well, we know at the y-intercept, we're looking for y, so x is 0, and we want to find out what y is. So x is 0. 4 times what equals 24? 4 times 6 equals 24. So there is our y-intercept. Our x-intercept, we're looking for x, so our y is 0. And 8 times what is 24? 8 times 3 is 24. Don't forget, guys, what we're really doing here. We're dividing both sides, 8 and 24. We're dividing it by 8. So 24 divided by 8 is 3. Okay, so you can look at it two ways. What are we multiplying by to get that? Or divide both sides out if you're not sure how to do it that way. Okay, now we know the slope in standard form is negative a over b. Our a is 8. Our b is 4. Put a negative in front of it. That gives us a negative 2. So our slope is negative 2. Now, another way we could get that is we have 2 points, so we could use our change of y over our change of x. That's the other way to find slope, right? So we could, our y's are 6 and 0, so 6 minus 0, over our x's, but since we started with 6, we got to start with the, we're going the same way, so 0 and 3, and we put the subtraction sign there, because change means find the difference. So 6 over negative 3. 6 divided by 3 is 2 with a negative in front, so it is still negative 2. All right, provide an equation in standard form whose graph is parallel. Well, we know that if the graph is parallel, the slope is going to be the same. So we really could use the same expression on this side because we already know that's going to give us a slope of negative 2. All we have to do is change the constant. So if we change this, let's say 20. Is the constant now, does that make a different y-intercept? Okay, we had a y-intercept of 6, and remember, in parallel, the slope is the same, the intercept is different. So 4 times what is 20? 4 times 5 is 20. So we changed the intercept, but we kept the slope the same. Now, we don't have to do that. There are other things we could do. Remember, all we have to do is get a slope of negative 2. So as long as our 2 coefficients, when we take a over b, as long as it gives us a slope of negative 2, we're fine. We could have used, let's say, 4x plus 2y and give it 10. All right, if we look at that, 4 over 2 is 2. Okay, with a negative in front becomes negative 2, so the slope stays the same. And 2 times 5 is 10, so we get a different y-intercept, so we're good. There are millions of equations that we could use, guys. So as long as we keep the slope the same and have a different y-intercept, we're good to go. Okay, let's look at the next one. Provide an equation in standard form whose graph is perpendicular. Now we know in perpendicular the slope has to be the negative reciprocal. So our slope before was negative 2, so we have to make it positive, and we have to use the reciprocal, which means we're going to flip it, right? So we get a half. 2, when you flip that, it becomes a half. Positive, negative becomes positive. Negative reciprocal. Now, we could write this down in slope-intercept form and change it, or we can use our noggin a little bit and say, well, wait a minute. 8 over 4 gave us 2. If I switch the coefficients and put 4 in front and 8 in back, and remember, perpendicular, we don't even care if the intercept is the same, so we could write down the same intercept. 4 divided by 8 gives us a half, but we want that to be positive, so wait a minute. If I put plus in here, that's going to be 4 divided by 8 with a negative, so how could I... Hey, wait a minute. Maybe if I put a minus in here, let's see. A over B with a negative, and we have the other negative in front. That's 2 negatives. That makes a positive. It works. So think about this for a minute. This one, 8 divided by 4, with a plus in the middle, gave us a negative slope. 4 divided by 8 with a minus in gives us a positive slope. Something to think about, guys. Maybe that's something we can use. We can talk about it a little bit more in class. See what you think. All right. Now, once again, we could use anything that would give us a half. So could we use, let's say, 2x minus 4y and whatever, 100? Of course, because this would give us a slope of 2 over 4 with those double negatives. So that gives us a positive half. And in this case, our intercept would be negative 25, which is obviously different from 6. Doesn't have to be. Remember, the intercept is not important as long as we have the same slope. Look at question number 4. It says, calculate the solution of the system y equals 5x plus 13 and y equals 2x minus 2. Well, we know both of these are in slope-intercept form, and we also know that if two things are equal to the same thing, we can set them equal to each other, and that's what helps us find the solution to this system. So since 5x plus 13 is equal to y and 2x minus 2 is equal to y, we can set these two equations equal to each other and find our common solution. So 5x plus 13 equals 2x minus 2. Okay. Now, we can put, let's get our variables on the same side. So we could either move this 5x over to this side or the 2x over to this side. I'm going to try and keep it positive, so I'm going to move my 2x's to that side. So since this is positive, I have to take it away from this side. Whatever I do on one side, I got to do the same thing on the other side. 5x minus 2x is 3x. I got to bring down my 13. 2x minus 2x is 0. So what do I got left on this side? I have a negative 2. Now, keep on going. I want to get my constants on the other side. Now I have all my variables together on this side. So I'm going to take away 13 from both sides. By doing that, I'm left with 3x on this side because 13 minus 13 gives me 3x. There's nothing left there for the 13 minus 13. And I have minus 2 minus 13. I put those together, I get a negative 15. All right. So let's finish this up. We'll do it up here. 3x equals negative 15. The coefficient of x is 3. And remember, coefficient multiplies the variable it's next to. So the opposite of multiplying is dividing. We're going to divide both sides by 3 because we don't want 3 x's. We want to find out how much 1x is worth. So 3 divided by 3 is 1. That gives us the 1x. Negative 15 divided by 3 gives us negative 5. So we've got half our solution. We know that the x part is negative 5. We still need to find the rest of that point of intersection, the y point. So what we can do to not only check our work, but also to find the y at the same time is write down our equality again. 2x minus 2 equals 5x plus 13. And we know what x is, so let's put it in. 5 times negative 5 plus 13 equals 2 times negative 5 minus 2. And we'll evaluate on both sides, see what happens. We get negative 25 plus 13 on this, for this side of the equation. On the other side, we get negative 10 minus 2. Negative 25 plus 13 is a negative 12. And on the other side, negative 10 minus 2 is also negative 12. So we know that we did our work right, and we also know that the y part of our point of intersection is negative 12. So our final answer, guys, the common solution, or the solution for this system, the point of intersection is at negative 5, negative 12. And we're done with question 4. Question 5 is a similar problem. We have both equations in slope-intercept form, so we can set them equal to each other. So we get x minus 7 equals negative 2x plus 14. We take the expression, the two expressions, set them equal to each other because the y's are equal. So let's get the x's on one side. Since we're subtracting 2x here, or it's minus 2x, negative 2x, I'm going to add 2x to both sides. The reason I do that is this way. Let's look at the right side first. Negative 2x plus positive 2x gives me 0, so I'm left with 14 on this side. And my x's are together on the left-hand side. X plus 2 more x's gives me 3x minus 7. All right. So now, I've got to get the constants together as well. So since I'm subtracting 7, if I want to get it to the other side, I have to do the opposite, which is adding 7. So I'm going to add 7 to both sides. Negative 7 or minus 7 plus 7 gives me 0, so I'm left with 3x on this side, and on the other side, 14 plus 7 is 21. Finish it up, I just got to divide both sides by 3. So x will give me 7. Okay. Now all I got to do is put them back in. So I'm going to write that equality again. X minus 7, that equation, equals negative 2x plus 14. And now I'm going to evaluate. So I know my x is 7. 7 minus 7 on this side. And negative 2 times 7 plus 14 on this side. I evaluate, replace the x with 7, because that's what we found. 7 minus 7 is 0. Negative 2 times 7 is negative 14 plus 14, and that also equals 0. So the left side is equal to the right side, and our y is obviously 0. So the answer, guys, our solution is x equals 7, y equals 0. X equals 7, y equals 0. There's the answer. Okay, that's the point where these two graphs would intersect. That's called the solution. If we were to graph these two, that's where these, that's the point of intersection. All right, so that's number 5. We're done. Final problem for this review pack. Graph an example of a system of nonlinear equations with no solutions. No solutions. So no solutions means we're going to have no points of intersection. And since we have nonlinear equations, we have to have at least some of the graphs on this system not being lines. So if I do, let's say, a parabola, something that looks like that. If I do another parabola down here that looks like that, I know that these two are never going to intersect. Why? Because this is going south. This parabola, they're heading north. These two are never going to intersect. So these are nonlinear. They're both parabolas. They're not lines. And they're going to have no solution because they're never going to intersect. Now, even if I add a line here now, and we know this is a horizontal line, right? Horizontal. Okay, it's laying flat. It has a slope of 0, as all horizontal lines do. You can see this line's gonna go on forever in this direction and this direction. It's never gonna go up and down. So now we have a system of 3 equations, 3 graphs, and none of them are ever going to intersect. So this is still a system of equations. This is just a system that has 3 equations instead of 2, and no solution because none of these are ever going to intersect.